Good morning. This week we're going to be still talking about area, but we're going to talk about some multi-step area problems. So for the first two, we're actually going to review two of the concepts that we have learned so far this year because you're going to need that to solve the questions below. Okay, so the first one, we're finding the value of x and we have a right triangle with sides 7 and 15, and we're looking to find the third side. Okay, now if we have a situation like this where we know two sides of the right triangle and we're looking to find the third side, we need to use Pythagorean theorem. So we need to use a squared plus b squared equals c squared. Okay, remember that c is always across from the right angle. So x, what I'm looking for in this case, is going to be my c. And then the a and the b, those don't really matter. So if I make 7a and 15b or the other way around, it's not going to change the problem. Okay, so let's plug in those numbers. 7 squared plus 15 squared equals x squared. Okay, so I'm gonna just plug this into my calculator. 7 squared plus 15 squared is gonna give me 274 equals x squared. And then if I want to get x by itself, I'm going to take the square root of both sides. So what is the square root of 274? It's about 16.55. Okay, so in this case, x is approximately equal to 16.55. All right, anytime you get a problem where you know two sides of the right triangle and you're looking for the third, always going to use Pythagorean theorem. All right, now in the second one, I have again a right triangle, but I know only one side of my right triangle and I'm trying to find this side, but I do know that this angle is 32 degrees. So if we only know one side, but we also know an angle, we need to go back to trig. We need to go back to SOHCAHTOA. I know it's probably been a while since you thought about this, but we need to go ahead and solve for x using sine, cosine, or tangent, okay? So if this is my angle, then x is gonna be my opposite side. Across from the right angle is my hypotenuse, and 14 is gonna be the adjacent side, okay? Remember, whichever one is blank is the one that we're not using, so we're using O and A, which means I'm going to plug into the tangent equation. Okay, this is on the formula chart. You might still have it memorized, but these tangent and then my angle 32 goes in the parentheses, equals, and then it's opposite over adjacent. So x over 14. Okay, anytime x is in the numerator, I'm going to multiply. So I'm going to multiply this side by 14, but those will cancel out. And I'm going to multiply this side by 14 as well. Okay. So I'm going to go ahead and make sure that my calculator is in degree mode. Remember, it's mode, and mine's not, so good thing I checked. Go over degree, and now we'll plug this in. 14 times the tangent of 32, and that's going to give me, if I round to the hundredth, approximately 8.75 for x. Okay, so that was a review of two of the concepts that you are going to need in order to solve these multi-step area questions. Okay, so for each problem, you're going to ask yourself these three questions. Number one, what area formula will I use? What area or what shape am I trying to find the area of? Number two, what measurements do I need to use the formula? So you might be missing one of the things that you need to plug into the formula. And then number three is, how am I going to get that measurement? Okay, so in number one, our first example says to find the area of the rectangle. Okay, so the first question that we're going to ask ourselves, what area formula will I use? Well, if I go and I look at my formula chart, the formula for the area of a rectangle is area equals base times height. Okay, so in my rectangle that we have here, the base is along the bottom and my height is along the side. Now, you can see that we don't actually have either of those things, okay? So we need to find the base and the height before I can plug in to this area formula. Okay, now the next question, number 2 is, or sorry, number 3, how can I get those measurements? All right, so if I look at what I've got here, I do have half of my rectangle as a right triangle, and I know this one side is 8, and that my angle right here is 30, okay? Anytime we know one side of the triangle and we're looking for another, we are going to use trig. We're going to use SOHCAHTOA, okay? So let's go ahead and let's find the base first, all right? So let's find my base here, all right? That means that I'm going to ignore the height, okay? So if I'm looking for the base, ignore the height, and then vice versa, all right? So the base in this triangle right here is going to be my adjacent side. 8 is my hypotenuse, and then the height is my opposite side, okay? So if I'm looking for the base and I have the height, I'm going to use cosine. So the cosine of my angle 30 equals, and then cosine is adjacent over hypotenuse, so base over 8, okay? So I'm going to go ahead and multiply, since the b is on the top, so 8 times the cosine of 30, and we will round that to the nearest hundredth if we need to. So 8 times cosine 30 gives me 6.928, so about 6.93. All right, now next we're gonna go ahead and we're gonna find the height. We're gonna do the same exact thing. This time we're gonna ignore the base and find the height. Okay, so I have O and H tells me that I'm going to use sine. The sine of an angle is still 30 equals opposite over hypotenuse, so H over 8, okay? Again, the variable is in the top, so I'm going to multiply 8 times the sine of 30, and let's see what that gives me. 8 times sine 30 gives me exactly 4, okay? So my base is about 6.93, my height is 4, all right? Now that we have both of those things, we can actually plug in to the equation now. So my area is going to be 6.93, which is what I found for the base, times 4 for the height. And all I need to do from there is just plug that into the calculator. 4 times 6.93 gives me about 27.72. My units are inches squared. All right, in our second multi-step area example sets to find the area of the kite, okay? So first things first, what area formula will I use? Well, the area formula for a kite is 1/2 times D1 times D2. Okay, now remember that D1 and D2 are all the way across the shape. So we need to, I know we have the 20 for that part, but we need all the way across, and then I don't have anything for the other diagonal. So I need to find both D1 and D2. Okay, now in a kite, every time we have the diagonals, they always make a right angle. So every single one of these triangles is a right triangle, okay? I don't know what the angle is, so right away I can knock off trig. I cannot use trig because I don't know what these angles are going to be. Okay, so really my only other option is how can I get those measurements? I'm going to use Pythagorean theorem in order to find the other things that I need, D1 and D2. Okay, so let's go ahead and let's start with D1. Okay, so in my picture, I have 2 right triangles right here. Right? And this right triangle, I know that one side is 20 and the other side is 25. Now remember, again, hypotenuse is always across from your right angle, but in this case, I'm going to use C since it's a squared plus b squared equals c squared. Okay? Remember that it doesn't matter which one is a and which is b, so let's say I'm going to do a squared plus 20 squared equals 25 squared. And then we just have to go ahead and solve this for a. Okay, so I'm going to square everything first. I don't know why I'm using my calculator for this. I know what the answers are. So a squared plus 400 equals 625. All right, and then a squared equals 225, and I'm just going to double check. 225, the square root of that is 15. Okay, so my a in this case is going to be 15. All right, now let's look at what that means in the picture, okay? That means that in this right triangle, this part right here is 15, okay? Now, that means that the other side in a kite is also going to be 15. So my D1 is actually going to be 30. That's the number that we're gonna use for D1, okay? And then let's go ahead and let's find D2. And actually, this helps us. Now that we found that this side is 15, we're going to use this right triangle in order to find the other part of that diagonal, okay? Again, across from my right angle, that's going to be my C. The other one does not matter, so let's do a squared plus, I'm just going to kind of differentiate there, a squared plus 15 squared equals 39 squared. Again, let's go ahead and let's solve this. I'm just going to do it a little bit faster here. So 39 squared minus 15 squared gives me 1296. Take the square root of that, and we get that a is 36 exactly, okay? Now, again, what that means in my picture is that this part right here, from here to here, is 36, okay? In order to get the full diagonal, we need to add those together. So 20 plus 36 is actually going to be 56. Why is my marker running out of ink? Okay, so last step is to go ahead and plug this into our area formula. So area equals 1/2. D1 is 30. And D2 is 56. Can y'all even see that? I'll just go over it in my block. So 30 and 56. Okay, then just plug that into my calculator. 1/2 times 30 times 56 is going to give me 840. Our units are centimeters squared. Okay, so there you have it, multi-step area. You might need to use trig or Pythagorean theorem or potentially something else in order to solve for the things that you need. And then the very last step would be to actually plug into whatever your area formula is. Okay, there's a practice that goes along with this. Y'all know, email me if you have any questions or comment on Classroom, and we'll also be posting anchor charts for trig and for Pythagorean theorem and those triples on Classroom if you need or want that.